Hi guys, welcome to Science Synthesis with Eze. For all lovers of science, creativity, critical thinking, let's dive into the process proper and enjoy ourselves in the world of science. Thank you.
Alright guys, now let's see how ice is formed. Water as a molecule is made up of two hydrogen atoms and one oxygen atom. And water molecule is dipole, that means the hydrogen and oxygen atom they have polar bonds. And because of this sole reason, the hydrogen atom of one water molecule can be attracted to the oxygen atom of another water molecule, hence forming hydrogen bonds. And water molecules are constantly moving because they possess energy and they are constantly moving. But in the liquid state, they have more energy than in the solid state. So when we cool the liquid, we are reducing the energy, we are reducing the potential energy. And as we reduce the potential energy, we are reducing the motion of these water molecules. So as we keep reducing the temperature, and we get to 0 degrees, we'll see that the molecules of water, they start sticking together, they start coming together because we're reducing the temperature and we're reducing the speed at which they move. But this doesn't just happen, some things will be set in place for them to start sticking together. And that should be a crystal seed. There should be a crystal seed. The seed can be an impurity or a disturbance. This impurity can be inside the water, or it can be a container which is holding the liquid. So these are the two basic things that must be in place, for ice to form. Alright, let's now dive into supercooled water. Since we cook the water below 0 degrees, and we still discover that the water was still in the liquid state until the point where we disturb it, and the time we added and mixed the water, that was when ice forming. So let's see the reason behind this. Alright. So for the first situation, we saw that when we added an impurity or anything inside the liquid, we saw that the crystals of ice started forming, which implies that the impurity at that point in time is serving as the crystal seed. And once we introduce the crystal seed, that is the very thing that will get started. So the molecules of water start clinging together at that point around that very impurity, and we saw that ice is formed. Also, in the second situation, we have to bump the molecules by applying a little energetic push to the container, and we saw the crystals of ice forming from that very point. So that push is now serving as the crystal seed, and that is the disturbance. And because of that, we now see the crystals of ice forming because of that very push. Now, in the third situation, we saw that we have a solid already, that's a solid ice. So like I said earlier, there must be something to get this started, be it a solid or an impurity or a disturbance. So when we place the solid and then we start pouring the liquid onto the solid, we saw ice forming because the solid at that point in time is serving as the crystal seed. It is serving as the crystal seed, and then we saw the crystals of ice being formed. So someone will now say at this point in time, does it imply that every water that freezes at 0 degrees Celsius is impure? No, that's not true. The water might be pure and it can still freeze at 0 degrees Celsius if there is a disturbance. If it is pure, then there should be a disturbance that will cause it to freeze at 0 degrees Celsius. This disturbance can come from the container housing the liquid. So this is something I want us to put in place. So the question, at what temperature does water freeze, is more complicated than it first appears. Now you've learned new thing about supercooling. Why not like this video, share it, and then turn on your subscription button so you can get notification when we post new videos. Thank you for viewing. I love you all.
Water as a molecule is made up of 2 hydrogen atoms and 1 oxygen molecule. So